This lesson is designed to help you write your proposal for your science project this year. At the top, you're going to want to include your name, your teacher, and the period that you have that teacher. You are allowed to work with a partner as long as that partner has the same science teacher. It's okay if they're in a different period, but you must have the same science teacher as your partner. If you don't have a partner, you can just leave that blank. After you finish your proposal, you are going to have someone proofread your document. Please include their name, and this is required, right up here at the top when you are done. So for your instructions for this proposal document, once you've found this document, you will have made yourself your own copy. So this is yours to edit and what you will be submitting. You want to fill in each bolded section completely. Once you have done that, you're going to remove the instructions. The instructions are in red. So when you're done with this document, there should be no red text left. You will have deleted all of the instructions, but you will leave the headings like topic, research question, rationale, and background so that your proposal is nicely organized. You want to make sure that your text is in black font, not red. So the red are the directions, delete that. When you type in, it should be in black font. When you are done, you will save your document as a PDF and upload it to Canvas or print depending on your teacher's instructions. So the first thing that you're going to include is the topic. This is the area of science that your project falls under. It could be biology, chemistry, physics, environmental science, whatever that general topic is, include that there. The research question comes next. It should be scientifically worded and clearly state the problem that will be investigated. This is not a place for cute titles or questions. Coming up next is a large section. This is going to be 2 to 3 paragraphs, and this is the rationale and background. These paragraphs will explain the justification and scientific theory behind the project. A later deadline is writing the introduction, which will be many more paragraphs than just 2 to 3, but focusing on the same rationale and background of your project. So doing a good job on this is going to help you when you go to write your introduction later. For this specific deadline, no in-text citations are needed, but you should be keeping track of your sources so that when you come to write your introduction, you'll know where those in-text citations belong. This section, you should explain the reason why your project is significant or interesting. Remember, why should someone care about your project? Describe and explain the science behind your experiment and your hypothesis. You want to make sure this is written in a passive voice with no personal pronouns. Personal pronouns are things like I, we, you, me, my. You want to leave those out when you're writing this section. After that comes the research hypothesis. This is your testable explanation for the observed phenomena. You are going to write this in the if, then, because format. Your hypothesis is not a wild guess. It must be informed by research. So you're going to start with if, and then you're going to say something about your independent variable. Then something about your dependent variable, and then because with some reasoning. So for example, if radish plants are treated with different fertilizers, that's the independent variable, different fertilizers, then those treated with Miracle-Gro will show the greatest growth. Greatest growth. Growth must be the dependent variable. Because Miracle-Gro has the highest concentration of nitrogen. That had to have been found from research. So this hypothesis is founded in research. After your research hypothesis is going to come the null hypothesis. This is the hypothesis that you will accept or reject after statistical tests. It claims that there is no significant difference between experimental groups and that any observed difference is due to sampling or experimental error or random chance. You will not know whether we can accept this or reject this until after you do your project, collect your data, and then run the statistical tests. But we're going to go ahead and write it now. When you write this null hypothesis, generally you can use the same first part of your research hypothesis, exactly the same. So if something about your independent variable, then what follows it is a statement that there will be no difference. So there will be no difference in the growth of the radishes between the groups for this scenario that we were working with. Next up, you're going to list your independent variable. So this is the variable that you will manipulate, you will change throughout the experiment. Projects require 4 levels of the independent variable unless you have gotten special approval from your teacher. Typically, the first level will be the control. Most projects, a control can be set up. There are a few exceptions to that. So if you're struggling identifying one, you can double check with your teacher that one exists. But for the scenario that we were working with, the control would be using no fertilizer, and then the other 3 levels would be using different types of fertilizer. Each level requires a set number of trials. So this is per level, not total. So all projects must have 10 to 20 trials per level. Plant projects in specific require a minimum of 20 trials. The reason why we require more trials for plant projects is just because plants have trouble growing sometimes. Data can get skewed. So we want to make sure that we have enough trials so that we can get some solid data when the project is concluded. Human projects must have 30 trials per level, which is a large number of trials, which is why human projects, we ask you to get that pre-approval done in the beginning because it does involve some extra work and extra time on your end. Okay, so these are trials per level. So for this project, it would be a minimum of 20 plants for the level 1, 20 for level 2, 20 for level 3, and 20 for level 4. So that would be 80 plants. So consider that when devising your experiment and choosing something that you can realistically set up and control at your house. Next up, you're going to list the dependent variable. You're welcome to have more than one, although one must be measured quantitatively. Quantitative data is numerical data, so you want to make sure that we can measure it and get a reading that is a number. Observational data or qualitative data may also be included as long as you have one quantitative dependent variable. You should also list the tool used to measure that dependent variable. Be sure you know exactly how to measure what you propose. So some research will be involved there to make sure you know what kind of data you need to collect and how you're going to do that. Do not assume that equipment is available without checking for it. If you are going to buy it yourself, look into the cost and how soon you can get it. Or if you are looking to borrow that from a teacher, again, ask in advance and see if that's something that is available. Next up, you want to include the units that you're going to measure your dependent variable in. These must be metric units. Things that are not metric units, cups, tablespoons, teaspoons, inches, all of those types of units must be measured in metric units like centimeters or millimeters, milliliters. And all of that you can find through research as well. You will then want to create some constants. Constants are going to help ensure that you are controlling the environment as best you can to isolate the effect of your independent variable on the dependent variable. You're going to do your best to keep everything else constant. So you want to list 5 constants that are non-trivial, saying things like you're going to be the one collecting the data, or you're going to, be wearing the same shirt every time. I mean, that stuff doesn't matter, or that stuff is obvious, so don't include those as constants. Think about things that would actually make a difference, and you're going to do your best to control. Next up is the procedure. So you want to describe in clear list format at least 10 detailed steps you need to carry out your experiment. So when your teacher is reviewing this, make sure you have a list starting here with number 1, and it should go until at least number 10. You want to include your materials that you will use within the steps. So instead of having a separate section of materials, just be specific as they come up in your procedure. For example, measure the height of the plant using a ruler in centimeters. So instead of saying that you need a ruler, you would just include it as part of your procedure. Include where you will purchase the materials. So doing that research, making sure you can get all of your materials. You can include where you're going to find those as part of your procedure. Insert any annotated drawings or photos of your setup if you think it's helpful in understanding your procedure and also explaining it to your teacher. Be as specific as you can to gain approval. If this is vague or unclear, your teacher is just going to send it right back to you and tell you to do some more work. Okay, so take your time now and do a good job on writing the procedure. We must also include risk and safety. So you must identify any potential risks and safety precautions needed. Show evidence of full awareness of the significant safety, ethical, or environmental issues that are relevant to the methodology of the investigation. Even if the considerations are minimal or none. I mean, that's the goal. We're not going to be doing anything very dangerous, but everyone must have something in this section that shows that you've evaluated all possibilities, all potential areas of potential risk, and that you have done a good job to mitigate them, and you've included the safety precautions that you will be taking throughout the experiment. You are then going to explain the statistics that you're going to perform to draw your conclusions in the data analysis section. Describe the type of graph or graphs that you will present. Most projects will have a mean, standard deviation, and ANOVA test. That's most projects. There are also other statistical analyses that if you're doing a different type of project, you may do instead. All projects will also have a graph, whether it's a line graph, that means your independent variable is quantitative, numerical, or a bar graph, where your independent variable is quantitative or categories. Finally, you're going to include an annotated bibliography. Your bibliography is going to come from Noodle Tools, and there are other lessons on Noodle Tools and research that you can access if you need help with those. We want to make sure that this is alphabetically arranged and divided into 2 sections. So these are your 2 sections here. Headings are already set up for you, peer-reviewed or scholarly, and then non-scholarly. You must have 5 peer-reviewed scholarly sources. You can have 0 to as many as you want non-scholarly. Okay, it's not required that you have non-scholarly, but if you use them, then include them. But you must have 5 peer-reviewed. Excellent papers will have at least 2 of the 5 as peer-reviewed journal articles. So for this section, instead of just including the sources for the bibliography part, you're going to annotate them, which means that you're going to write 2 to 3 sentences for each source describing the information from the source that will be useful to your research. This is going to help you later on when you're writing your introductions. You'll have a list of a bunch of good sources that you found, and then also a short synopsis so that you know when to use each source for different parts of your introduction. List the sources below with the annotations directly below the matching source. Okay, so I'm going to show you guys what an example looks like. So this is an example proposal where the student has put their name, their teacher, their period, and their proofreader. This student used a mentor for their proofreader, which is an excellent idea. Their topic was environmental science. They have their research question and their rationale and background. This document is available to you all on the Science Project Help course if you want to read it in more detail. The rationale and background is written in paragraph form, and it's 2 to 3 paragraphs. The research hypothesis is written in an if, then, because format. There's a null hypothesis, the independent variable with 4 levels, the number of trials that they are choosing to do per level, the dependent variable, some constants, the procedure written in list format, so at least 10 steps. And this student has also included some drawings with annotations that they did of how they are going to set up their project. There's risk and safety, how they are going to analyze their data, and then a bibliography that's been annotated. So it includes the sources written in APA format following their Noodle tools, and then a short 2 to 3 sentence summary below indicating what information that they found in those sources that's going to be helpful to them later when doing more research and writing their introduction. And this student had no non-scholarly sources, and that is totally fine. All right, so once you finish your proposal, if you are using Google Docs, which you all should be, if you made the copy to get here, you are going to go up to File, and then you are going to go to Download, and then PDF. Okay, so File, Download, PDF, and then you can download that document as a PDF, and it should appear in your Downloads folder. And then you can upload that to Canvas. If your teacher has asked you to print this out and turn it in instead, you go to File, and then at the bottom here, Print.